everyone. We are going to look at amplitude changes today. Amplitude, remember, is the height of the function. Remember I talked about the importance of kind of the four corners of the graph or the circle. So at 0 pi, half a pi, pi, 3/2 of a pi, and back to 2 pi. And remember the sine wave and the cosine wave have curvature. But we are just going to focus on those 4 points when we fill out and compare. So when we talk about the parent graph, and that's what we did already, the sine at 0 is 0. The sine at pi over 2 is 1. The sine at pi is 0, -1, and back to 0 again. And if you have markers or colored pencils, this might be a good time for you to grab those, because then we can compare on our graph here. So if 2 pi is way down here, we're going to make 1 pi, half a pi, 3/2 of a pi, and then notice our y-axis is labeled as high as 3. So that means we have 1 and 2, -1 and -2. So now when I go and graph the parent function, I have 0, 0. At half a pi, we went up 1. Then we're back to 0 again, down to 1, -1, and back to 0. And please make sure you still remember the curve that we found in the parent graph. Alright, so what is it saying when we add 3 times the sine? Well, basically what we're doing is we're multiplying by 3. So we're going to find the sine. So again, what is the sine at 0? It's 0. And then what's 3 times 0? It's 0. What is the sine of x? What is the sine value at 1/2? It's 1. And now 3 times 1 is 3. What is the value of sine at pi? It's 0. And 0 times 3 is 0. What is the value at 3 pi over 2? It's -1 times 3 is -3, and we're back to 0 again. So now when I go to graph my green graph, I still have 0, 0, but this time it goes as high as 3 and as low as -3. So we would say here that it had an amplitude of 1 because it was 1 high or 1 low with my brown graph. And now I have an amplitude of 3 high and 3 low. Remember, amplitude is when it cuts at the midline. It's the same distance up as it is down. So I'm going to change colors here again. And now let's do the sine -2 times the sine. So the sine at 0 is 0 times -2 is 0. Half a pi is 1, but 1 times -2 is -2. At pi it's 0. -1 times -2 is a +2. And we're back to 0 again. So what happened when we multiplied by a negative? We still start at 0, 0, but this time it goes down and then up. And if you think about when you learned about parabolas back in Algebra 2, if A was negative, the parabola went upside down. If A was positive, the parabola went up first. So that should kind of make sense why the negative flipped it. What do you think is going to happen when we multiply by a decimal, or essentially a fraction? Again, we're going to multiply our parent graph. 0 times 1/2 is 0, times 1 is 1/2, times 0 is 0, -1/2, and 0. So this time we have 0, 1/2, 0, negative 1/2 and 0. So what happened when we multiply by a fraction? The curve gets even flatter. So my amplitude here was only 1/2. So what does adding an a in front of the function actually do? To change the amplitude, we multiply a number in front of the function. And then we talked a little bit already about what a negative sign does in front of the function. It is a reflection. Or in other words, it flips the function. So instead of going up, it goes down first with the sine wave. Okay? So if you turn the page now, you have you have 6 problems to do. What I want you to do is notice that some of these are sine and some of these are cosine. So make sure you take and look at that. I also want you to make sure you answer the questions over here about the period, the amplitude, the domain, and the range. If you have any questions, we'll work through those in class, but work on the next 6 problems.